Hi everyone, today we are going to determine the moment of inertia of this shaded area about the x-axis and y-axis. As you can see in this figure, the horizontal distance is 1 meter and the vertical distance also 1 meter, and the equation of this curve is y cube equals x square. So you can see that the shape is not a regular shape, so we have to consider a horizontal strip or vertical strip to find the moment of inertia about x or y axis. So we consider horizontal strips, or you also can done by vertical strips. So the coordinate of this point is x, y, and the vertical height of this small strip dy. So the horizontal distance will be x from y-axis to this point, and the vertical distance from this section to x-axis is y. So let's find the moment of inertia about the x-axis. Ix equals integration y squared dA. So here y means the distance from axis to CG. So the distance from x-axis to CG is y. So this one will be y squared, and the small area dA. So the small area of strip dA equals, so this one is a rectangular shape, so the area will be horizontal x and vertical dy, so x dy. So let's put the dy dA in here, so x dy. So the limit will be in this equation, limit will be with respect to dy. So the upper limit of in this y-axis is 1 and the lower limit is 0. So the upper limit 1 and lower limit 0. And as you can see in this curve equation, here we can write x equals y to the power 3 by 2. So let's put x equal to y to the power 3 by 2 here. So upper limit 1, lower limit 0, y square y to the power 3 by 2 into dy. So as now sum the power of the y, upper limit 1, lower limit 0, y to the power 3 by 2 plus 2 will be 7 by 2 into dy. Now integrate, after integrating, y to the power 7 by 2 plus 1 divided 7 by 2 plus 1, upper limit will be 1, lower limit 0. So after sum 7 by 2 plus 1 will be 9 by 2, so 2 by 9, y to the power 9 by 2, upper limit or lower limit 0. So 2 by 9, after putting upper and lower limit 1 minus 0. So this one will be 2 by 9. After calculating, this one will be 0.22 meter to the power 4. Answer. Now let's find the moment of inertia about the y-axis. Next, the moment of inertia about y-axis. After getting into that, now you can see if this one is a rectangular shape, whose horizontal is b and vertical distance d, if the axis is here, let's put a, b, and this one will be c. So inertia about AC axis db cube bhag 3 from the parallel axis theorem. So this one will be done by this same way. So the moment of inertia about y axis Iy equals ekhane dy into x cube divided 3. This one will be diy iy. Now integrate dy x cube divided 3. Now limit will be with respect dy. So limit in this y axis upper is 1 and lower is 0. So this one will be 1 and 0. On by 3 on 0 x cube equals, from here we can write that y to the power 3 by 2 3 into dy. On by 3 1 0 y to the power 9 2 dy. Now integrate on by 3 y to the power 9 by 2 plus 1 divided by 9 by 2 plus 1, upper limit on, lower limit 0. So 1 by 3 y to the power 11 by 2 divided 11 by 2, upper limit 1, lower limit 0. 1 by 3 2 by 11 and y to the power 11 by 2, upper limit 1, lower limit 0. So 2 by 3 into 11 33, upper limit 1 minus 0. So this one will be 0.060 meter to the power 4. So this one answer. Now already we find the moment of inertia about the x axis is 0.22 meter to the power 4 and moment of inertia about the y axis 0.060 meter to the power 4. So thank you.